In this video we are going to discuss about Azure Virtual Network. So till now we have discussed about cloud computing basics, and we have discussed about the basics of Azure, like introduction about Azure, why we require to have an Azure and what are the benefits of Azure, and how you can create a subscription in Azure. So now, assuming that you have already created a subscription and you are able to log into Azure using portal.azure.com with your credentials. So once you log into that one, there are a lot of services that are available. The first service that we are going to discuss now is about Azure Virtual Network. So let's see what are all the topics that we are going to discuss in virtual networking. So the agenda here is that overview of Azure networking, virtual network benefits, understanding network resources, creation of virtual network using Azure portal, creation of subnet, creation of network security group, that is NSG, creation of network interface code and public IP, and understanding and using Azure DNS. So we will not be just having a theoretical session in this video. Once we are done with the introduction of Azure virtual networking, subnets, NSGs, NICs, public IP, then once we are done with these things, we will be entering into the Azure portal, and I'll be showing how to create all these things through the portal. So first is a virtual overview of Azure networking. So what is meant by an Azure virtual networking? An Azure virtual network, which is also called as a Azure VNet, it is a representation of your own network in the cloud. See, if you see on-premise instances, actually, you will be having your own network, which is a kind of isolated. In a similar way, in the cloud also, if you would like to have for your company, if you would like to have an isolated network, then you can create an isolated network for your company alone, which is called as a virtual networking. It is a kind of logical isolation of Azure cloud dedicated to your subscription. So for your particular subscription, you can create a virtual networking which is isolated, and it can be accessible only within your subscription, and the outside subscription guys cannot access it. You can fully control the IP address blocks, DNS settings, security policies, route tables within this network. So in this network, whatever the controls that you would like to do, as I said, IP address blocks, DNS settings, security policies, route tables, everything you can control within this network itself. You can also further divide. Once you create a virtual network, inside a virtual network, you can also further segment your virtual network into a subnets. So you can segregate those virtual network into multiple subnets, and within that subnets, you can launch your virtual missions, or you can have platform as a service role instances as well. You can connect the virtual network to your on-premise network. If suppose you have created a virtual network which is isolated, which I have already discussed. Now, if you want to communicate your resources that are available in your virtual network with the outside resources that are available outside of your virtual network, maybe the resources that are available in your virtual network would like to communicate with the resources that are available on-premise instances. Okay, so you can have a communication, you can have a connection of your virtual network resources to your on-premise network using the connectivities options that are available in Azure. The connectivity option is like a site-to-site connectivity, express routing, point-to-site connectivity, which I will be discussing in the next video about the connectivity. So it is possible that the resources that are available in your virtual network, they can have a communication with your on-premise network, or also the resources that are available in your virtual network within your subscription can have a connection with the resources that are available in some other virtual network as well. In essence, you can expand your network to Azure with complete control of IP address blocks with the benefit of enterprise Azure provides. So let's see actually how was your on-premise network when it is compared with the Azure virtual networking part. So on the left hand side you can see the on-premise network, and on the right hand side you can see the Azure network. Okay, first let us concentrate on the on-premise networking. So assuming that you are connecting from the internet, you are sending a request through your internet. When you send a request, first it will be coming to the router, and from the router the request will be sent to the firewall. In the firewall it will be identifying whether the request can be sent further to the internal things, or whether it has to be get blocked. So the firewall will decide based on the conditions that you have set up over there, and the request will be sent to the internal load balancer if the firewall is allowing. The internet facing load balancer will consist of multiple web servers, the physical servers or the virtual servers. The multiple servers will be available. So once you send the request, once the request is received by the internet facing load balancer, based on the traffic, based on the availability, it will be sent to the any one of the 3 web servers. The request will be processed by these web servers, and if they require to get any data from the database, then the web servers will be sending the request further down to the internal load balancer where our database servers are residing. So before sending the request from web server to the database servers, internally there will be a firewall which will be checking the conditions, and based on that one it will be sending to the internal load balancer, and internal load balancer will again have different database servers that are connecting to the load balancer, and based on the request it will be sent to any one of the database servers, and the request will be get processed over there. So if you see a router with the firewall condition blocking in order to whether to give the access or not, and the internet facing load balancers which is an external load balancers, and the internal load balancers available. So here you can see again you can see a DNS is used for the name resolution here, and DC domain controller will be used for the authentication purpose. In addition to that one, you have a DMZ. DMZ here means actually dematerialized zone. So this will be available when your load balancer when your servers are exposed over the internet. Then you will be having a dematerialized zone, and this dematerialized zone is a physical or a logical subnetwork that separates an internal LAN from other untrusted networks, usually the internet. So it is a kind of logical or a physical subnetwork that is used for separating the internal load LAN local area network from other untrusted networks. So you see here, so let's compare this one, the on-premise one, with the Azure part. So when a request is sent from the internet, first here instead of router you have a Azure infrastructure. So in the Azure infrastructure you will be creating a dotted lines, you can see here, which is called as a virtual network. So you have created a virtual network and the request will be sent inside. So when the request is sent inside, like the firewall you have over here, you will be having a network security group. So network security group is the one which will be checking based on the policies that are assigned to that one, the security policies. It will be identifying whether the request can be sent or whether the request can be accepted or not. So once it accepts the request by the network security group, the next part is it consists of two subnets. One is the front end subnet which will be exposed over the internet, and the second one is the back end subnet which will be performing internally itself, which will be communicating only within the network itself. So Once the NSG has accepted, it will be sent to the public facing load balancer. In the public facing load balancer, again like the same way here, you have 3 web servers. Here you have 3 virtual machines. Okay, so the request will be sent by the load balancer to any one of the web servers, and once it is processed, in the similar way it will be sending for the data to grab the data from the database, and again you will be having again one more NSG which will be accepting the request, and the request will be sent to any one of the database servers of the virtual machines. The same way here you will be having a domain network name resolution once, and you will be having a authentication purpose. So here you will be having all the virtual machines. Here instead of firewall you will be having an NSG, and you have the load balancers, internal load balancer, and as well as the public facing external load balancer that is available here. So this is how we will be configuring when you are moving out from on-premise to the Azure. These are the list of services that you will be using, and then this is how you will be setting up the networking. So as I said already, in the domain, in the on-premise one, if any site, if the application, if the web servers are exposed over the internet, then you will be using this demilitarized zone. And also you can see that the Azure infrastructure takes on the role of the router, allowing you to access to VNet. So instead of router there, you have used VNet, and then instead of firewalls, you have used network security groups. And then and the network security group is applied for each and every subnets. And load balancers, the physical load balancers that are available on the on-premise are substituted by internet facing and internal load balancers in the Azure. Okay, let us see the pricing of the virtual network. By default, when you are creating a virtual network, by default there will not be any charge that is associated for creating a virtual network. But inside a virtual network, whatever the resources that you are creating, like if you are creating a virtual machine, then the charge will be applicable for the virtual machine that you have created. And if you are using a public IP address inside a virtual network, then it will be charging for the public IP address. If you are using a VPN gateway, then for the VPN gateway it will be charged. But if your virtual network is created with an empty virtual network, then there will not be any charge for the virtual network. It is going to charge for the virtual machines, the VPN gateway, and the public IP addresses, the resources that are created inside a virtual network. For those things alone, it will be chargeable. What are the benefits of virtual network? So I was keep on saying, actually the virtual network, that whatever you have created, it is going to be an isolated one. So only the people who are inside, they will be accessing only the resources inside the virtual network can access or communicate or connect each other. This allows, so if you see in the isolation, VNets are completely isolated from one another. This allows you to create disjoint networks for development, testing, and production that use same CIDR. So I'll be explaining what is meant by these CIDR address blocks, but you see, for each and every virtual network, it has its own disjoint and networks for development, testing, and production. Each virtual network will have its own IP address ranges. Access to the public internet. By default, whenever you are creating a virtual network, all the resources that are created, all the virtual machines or the PaaS roles instances in a virtual machine can have public internet by default. But if you want to make anything as a private one, then you have to control the access or by setting up the policies in the network security group. Next point is access to VMs within the virtual network. PaaS role instances can be launched in the same virtual network, and they can connect to each other using a private IP address, even though they are in the different subnets without need to configure a gateway or public IP address. That's true. In a virtual network, it doesn't matter how many number of subnets you create and in which subnet you are going to create a virtual machine. Within a subnet, let's assume if four virtual machines are created, four virtual machines can communicate easily each other by using the private IP addresses itself. They do not need a public IP address to communicate among each other, as they are residing within the same VNet. It's not really required. But if a virtual machine which is outside of a VNet, and if you would like to communicate to that particular virtual machine, then at that point of time you may be required to have a public IP address and the VPN gateway and all those things. But if the resources are available within a VNet, and if you would like to communicate within the with the resources that are available within that VNet, then it's not really required to have a public IP address or VPN gateway, and you can just go ahead with the private IP address alone. And name resolution. By default, Azure provides an internal name resolution for the IaaS virtual machines or PaaS role instances that are deployed in the virtual network. But again, you can also deploy your own DNS servers and configure the VNet to use them. If you have your own DNS server, then obviously you can use the DNS server DNS as well, and you can configure in the VNet and you can use them. Else, by default, Azure can provide an internal name resolution for these things. Security. Traffic entering and exiting the virtual machines can be controlled using the NSGs. As I said, on the on-premise, like the way that you are using the firewalls, in a similar way, here in the Azure virtual networking, if you want to control the access, the traffic entering and the exiting the virtual machines, then you have to control the traffic by putting some policies or by putting some conditions in the network security groups. Connectivity. VNets can be connected to each other and even to your on-premise data center by using site-to-site VPN connection or express route connection. Okay, so if you want to communicate, if your resources wanted to that are there in the VNet, if they want to communicate with the on-premise instances or with the other VNet resources, then they can communicate, they can connect by using the site-to-site VPN or a point-to-site VPN or a multi-site VPN or by using the express route connection, which I will be discussing in the next video. So the first thing is that before creating a virtual network or before creating a virtual machine, first thing that you require to understand is that first create a virtual network. First come up with an architectural diagram where how many number of virtual networks you have to create. Within that, what is the IP address range and how many number of subnets you would like to create, and what should be the NSG groups that you would like to set up, and what is the NIC, and then create the virtual machine. But don't create a virtual machine first and then later understanding like, okay, I have to create a virtual network, and then you would like to move the created virtual machine from a different location to this virtual network. This is a lengthy thing which is going to be a complex one. That's the reason, instead of doing a reverse case, I would say like first create a virtual network, create a subnet, and then go ahead and create a virtual machine inside that VNet and the subnet spots. Okay. Next, understanding network resources. Okay, so there are two types of IP address ranges actually. So IP address available in the networking. One is public IP address and the other one is the private IP address. If your Azure resources has to communicate with the internet or other public facing services like Redis cache, storage, Azure SQL, Azure Key Vault, then you have to go ahead with the public IP address. So public IP address in a sense, if you want to communicate, if the resources that are available in your VNet, if they want to communicate with the internet, and if they want to communicate with some other public facing services, then you have to go ahead with the public IP address. It can be either a static IP address or a dynamic IP address that are assigned to the virtual machine. So that are assigned to virtual machine, internet facing load balancers, VPN gateways and application gateway. So here you need to understand that if you are assigning a dynamic IP address, then it is going to be much more cheaper than assigning a static IP address. And private IP address, if you want to communicate the resources that are available within a network, can communicate each other by using a private IP addresses itself. You need to understand that public IP address is going to be charged. So if you really require to have a public IP address to your resources, then only use it. Otherwise, use a private IP addresses if you would like to communicate the resources within a network itself. Or else you can do one thing. If 3 web servers are there and if they are mapped to the traffic using a load balancer, then for a load balancer alone you give a public IP address, and for the web servers, as it is communicating through the load balancer, the web servers can have a private IP addresses which will be mapped to the load balancer, and load balancer will be having a public IP address which will be connecting to the internet. Like that you can go ahead and use it. Okay, what are the preferred IP addresses for the intranets? So you, based on your company, so this is not mandatory that you have to follow it, but the best practices that normally suggested in the networking concept here is that based on the company size, based on the number of IP addresses that the company may be required, there are certain range of IP address notations that are available, which we will be seeing now. Okay, if your company is very small company, or if you need a very small networks like a 250 IP address range or something like that, then you go ahead with the IP address range of 192.168.0.x for 2 power 8 systems. So the IP address range is 192.168.0.0/24. If you see 192.168.0.0, so for every, so each one is a byte, means 8 bits. So 8.8.8.8 means total is going to be 32 bits. So out of 32 bits, now you have made 3 bytes as fixed, means 888 is fixed, only one is changing. So what you have to do is 192.168.0.0/24, because 324 means 888 is going to be fixed and only the last 8 is going to be get changed. Means how many IP address you can create with this one, means if you want to know, every time it is going to be 2 power 8 dot, like 2 power 8 dot 2 power 8 dot 2 power 8, means it is going to be 255. It starts from 0, means total 256 missions, means 256 number, means it is from 0 to 255. So finally you can create up to 255.255.255.255. So here we have 192.168.0.0/24. So how we can calculate, like how many missions can we create, in the sense, totally you have 32 minus 24. So this is 24. So 32 minus 24 is going to be 8. So how many missions you can create is 2 power, here the number is 8, means 2 power 8, that equals to 256. 256 means you can create from 0 to 255. So here what I can do, 192.168.0.0 to 192.168.0.2 1.255. At max I can create up to these many number of machines. If I want to have one more network, then I can create how it is like 192.168.1.0/24. like this you should give. So at that point of time, what it is going to be 192.168.1.0 to 192.168.1.255. so like this the IP address notation you should be calculating. So you guys need to understand this one, because you have to set up this IP address rotation while creating a virtual network VNet, and as well as while creating a subnet you should be mentioning these details. So for a small networks, it is going to be 192.168.0.x. For a larger networks, where you may be required to create more number of virtual machines, there more number of IP addresses, then it is going to be 172.16.x.x. If it is x.x means what it is going to happen? What is the number there? 172.16.x.x. So as I said, 8.8.8.8, right? Out of that one, how many are fixed? Only 2 are fixed. Means 8.8 plus 8 is 16. So what it is going to be? 172.16.0.0/16. So 16 are fixed and 16 can be get changed. So that is how you will be creating this IP address notation. So the next one is only 1 is fixed, remaining 3 are can be changed. So it is 10.x.x.x. So if it is like that, then 8.8.8.8, out of that only 1 8 is fixed, the remaining can be dynamically changed. Means it is 10.0.0.0/8. Only the fixed one is 8. The remaining, how many machines I can create now? 32 minus 8 equals to 24. Means 2 power 24 machines I can create. IP addresses I can generate. I mean to say, like, not the machines, sorry. So I was talking about CIDRs. What is CIDR block here? So whatever the notation that you have given here, this is called as IP address notation is called as a CIDR block. Means classless interdomain routing notation. So how it is? The notation is constructed from an IP address, a slash, an IP address, a slash, and a character and a decimal number. The number is count of leading 1 bits in the routing mask, traditionally called the network mask. I was saying, right? So here if you see 128.42.0.0/21, in this one, in the address space, 128.42.0.0 is a network address, and 0.0.0.0 is a host address. You can create 2 power 10 IP host addresses from the address space. So this is basically a best practice which you can follow based on the number of networks, number of IP address that you require, whether it is a small, whether it is a large, or whether it is a large, very large. So based on that one, you can follow any one of these notations. Now subnets. So assuming that you have created a virtual network with an IP address range, inside that one you can segregate the the virtual network into multiple subnets inside that one. So subnet is a range of IP addresses. If you have 256 machines inside a IP addresses inside a virtual network, you can segregate the 256 into multiple subnets as a group, as a range of IP addresses. You can divide a VNet into multiple subnets for your organization, and as well as for security purpose also, for each and every subnet you can maintain a different security groups. So for the security purpose also, you can create a subnets inside a virtual network for easy maintenance. Virtual machines and pass role instances deployed to subnets within a VNet can communicate. So I was saying, whatever may be the resources that are available in a virtual network, irrespective of whether a virtual machine, whether a resource is available within a same subnet or a different subnet within that same network, if any resource that is available within a same virtual network, then it can communicate each other using a private IP address itself, and there is no need of having any kind of extra configuration. You can also configure route tables and NSGs to a subnet. Yes, for each and every NSGs can be applied at the subnet level, or NSGs can be applied at the virtual machine level as well. So if, by default, it is better to maintain the security groups at the subnet level, because if you are granular level, if you are going down and then if you are assigning the different network security groups at the virtual machine, then it will be tough for the maintenance part. So that's the reason, as much as possible, try to maintain at the subnet level. But if it is mandatorily, if there is any kind of policy that has to be assigned individually for a virtual machine, then you can go ahead and control that, assign that network security group differently for a virtual machine as well. Based on the number of systems in a network, subnet mask is set. Within each subnet you can have try to understand actually what it is like. You have created, so now let's assume that I have created 192.168.0.0 to 192.168.0.255. These many number of IP addresses I can create, 256 IP addresses, right? Out of these 256 IP addresses, you cannot use 5 IP addresses. The first 3 IP addresses and the last IP address are reserved and cannot be used for the VMs. The first IP address is going to be a subnet address, and the last IP address is going to be a subnet broadcast address. It means you cannot use, how many you can use out of 256? You can use only 251. The first 4 and the last one cannot be used, which you should be understanding. So here I cannot use 192.168.0.0 to 192.168.0.3, and then the last one is 192.168.0.255. These are the IP addresses which I cannot use. Remaining 251 I can use it. Okay. So network interface card. So network interface card means the VMs can communicate with other VMs and other resources on the network by using a virtual network interface card. With the help of, so what it is like actually whatever the policies that you are setting it up, all the policies will be set for the network interface card, and the network interface card will be attached to a virtual machine. So the virtual machine is a kind of VMs can have more than one virtual network interface card for different configurations. You can remove the NICs from the virtual machine, and then again you can attach the NIC to a different virtual machine as well. So the policies that are set over there will be attached to a different virtual machine. Next, NSGs. You can create NSG to control inbound or outbound access to network interfaces. As I said, you can control the traffic entering and exiting through network security groups. You can assign the network security group to an NICs, or you can assign that to the subnet. Each NSG contains one or more rules specifying whether or not the traffic has to be approved or denied based on the source IP address, source port, destination IP address, and destination port. And then Azure Load Balancer, virtual machines and the app services, the web app services in a virtual network can be exposed to internet using Azure Load Balancer. There are two types of load balancer. One is external load balancer. You can use external load balancer to provide the high availability for virtual machines and PaaS services that are accessed from the internet. Anything that is exposed over the internet, that is an external, for that you should be using external load balancer. And if you would like to communicate internally within the VNet itself, then you can use the internal load balancer. So these are the different things actually. So now you have understood what is meant by a virtual network, and then what is a subnet, what is network security group, what is a network interface card, what is meant by a load balancer. So now let us try to create those topics, that whatever we have discussed as a part of theoretical part, let us try to create them in Azure portal. So if you see, actually this is Azure portal where you can go ahead and create the virtual networks. So let us create a virtual network now. So go in the search bar and then type virtual network. So you will be seeing virtual networks classic and as well as the virtual networks. So no need to so classic is a pretty older one, so no need to think about that one. So just click on virtual networks. So in the virtual networks screen, you can see that actually there are no virtual networks that has been got created. So in order to create a new virtual network, click on add button here. Okay, so you have to give a virtual network name like do a VNet test 1, and then the address space, and the address space is maybe 192.0.0.0/24. Whatever the address space that you would like to give, so that it is showing here. You can create at max 256 IP addresses which starting from 192.0.0.0 to 192.0.0.255, which we have discussed in the earlier topic. So what kind of subscription it is. So if you have any free trial, then it is going to be a free trial. If you have any other subscription, you can select the list of subscriptions here. And the resource group, okay, before creating a virtual network, I think you can create a resource group. So I'm creating a resource group right now. Click create and then give a name, record resource group. Okay, and then in which location you would like to create this virtual network. So let us select so there are a lot of regions that are available on the data centers. So you can see US West, US 2, and then US East US, and then US East US 2. Let me select the East US, and then by default there will be a one subnet that will be getting created in this one. So give subnet 1, and the IP address range is going to be one 192.0.0.0/ maybe give 27, 28 maybe, yeah, so that you can create 16 addresses here. These things we can discuss later, like DDoS, the service endpoints, on the firewall related thing. So click on create. So what you have done is you are trying to create a virtual network called VNet test 1 with an address range of 192.0.0.0/24, which consumes around 256 addresses. You can create under the subscription free trial, and this is the resource group that we have created, that is record RG, and the location is East US. In East US you are creating with one default subnet, that is subnet 1 with 16 addresses inside that subnet, and then click create. So when you click on create, you can see that actually the status will be shown over here. Yeah, you can see the status, initializing the deployment, initializing the template deployment to resource group record org. Under record org, now we will be seeing one virtual network. So it's taking some time to create a virtual network. Let me stop. Okay, deployment is succeeded. So a deployment has been created. So just let us go here and do the refresh so that you should be able to see the virtual network that has been got created here. Yeah. So you can see under virtual networks now one virtual network is available with the name vnet test 1 under the resource group record org in the location East US under the subscription free trial. If you click on that one, then you will be seeing there are a lot of options that are available. So what we have done here is like we have created one subnet. So let's click on the subnets and see. So first let's see the address space. So the address space for the vnet 1 is 192.0.0.0/24 and the subnets here is you have created one subnet with the name of subnet 1 with the see here there you have seen that when you are creating a subnet 1 it was showing 16 IP addresses, right? 16 addresses. Out of that I said first 4 and the last one will be blocked by the subnet itself, so that you have how many IP addresses that you can use. You can create up to 11 IP addresses, and this is not attached to any security group. So let us go ahead and create a security group, and or else let's create one more subnet maybe inside this one. So I'll be subnet 2 with a network security group. Let us create one security group. Okay. Okay, let me create a network security group first then, otherwise. In order to create a network security group, type network security groups. Again, skip about the classic and then go to network security groups. In the network security groups, okay, let me show you what exactly we will be creating now here. So as per this diagram, let's try to create. So you have created a vnet and you have created a subnet, two subnets, subnet 1 and subnet 2. Subnet 1 will be external facing, means you have to have an RDP access to that one, and you have to have a web rule. HTTP should be allowed as an inbound rule, and subnet 2 should be only internal facing. Internal facing in the sense you should be blocking HTTP. Deny should be happening, and you should allow SQL server. So MS SQL should be allowed. Means you have to create two different network security groups for one subnet to allow RDP access and to give a permission for HTTP web requests, and the second one is HTTP deny, and MySQL should be allowed. Okay, let's try to create it now. Okay, I went to the network security groups, click on add. Okay, give a network security group, maybe subnet 1 NSG. Subscription is a free trial. Resource group is going to be record org, and the location is east US. Click on create. So now we have created one NSG, that is subnet 1 NSG, which is getting creating now. Okay, so one NSG is getting created. So for this NSG, now I did not add these rules yet. So now in order to add these rules, let me open this subnet 1 NSG and click on inbound security rules. Now I would like to give a control for the inbound security rules. Okay, click on add. In the add, what I have to do, what kind of service I would like to give an RDP permission, means RDP 3389 with allow RDP. Okay, so whether I have to allow or deny, so if you see here, action should be allowed. So here priority in the sense, actually in which priority the rule should be get executed. The minimal the number, the lower the number, the higher priority it is going to be. So it is going to be 100, 101, 102 like that. So I would suggest that give the priorities like 100, 200, 300, 400 like that, so that in between 200 and 200, if you would like to add any other priorities, then instead of changing all the priorities, you will be having certain spaces like 110, 120 you can create at the later point of time as well. So priority should be the lower if you want to give more priority to that one. Click on add, so that we will be adding one inbound rule, that is RDP 3389 to be added, so that whatever the VMs that you create inside this subnet, all those VMs will be having the RDP permissions now. Next, I will be creating one more to allow HTTP. So click here, basic. So click on the service HTTP. So 80 permission. So allow web, and then click on add. So you have, so for this one, for the subnet one, whatever the subnet that whatever the NSG that you would like to create, you have created the NSG, and you have allowed the RDP, and also you have allowed the web. Okay, now let us create one more network security group. Add subnet 2 NSG, and the resource group is record org. Click on create. Okay. Okay, now network to subnet to NSG has been got created, and inside that one, now what we should be doing, we should be allowing the MS SQL but denying the HTTP. So let's see. So inbound rule, what you should be doing, you should be allowing the MS SQL request. So go here in the basic, click on service MS SQL and allow SQL. Click on add. So the next step is that I should be denying the HTTP. So let it get created, so that I will be creating an outbound security rule. So in the outbound security rule, what I should be doing is add source HTTP and deny web. In the advanced, just go ahead and click on deny. So you are denying the rule. You are denying the HTTP. Okay, so now we have created the NSGs. Now next step is that we have to attach these NSGs to the subnets. So let's go to virtual networks again. Virtual networks. Okay, so you have one virtual network VNet test one. Inside that one, go to subnets, and then okay, we have only one subnet. Okay, let me attach to this one subnet NSGs. Okay, I have to attach subnet 1 NSG to the subnet 1. Okay, click on save. Okay, now if you see on the subnets, now under for subnet 1 NSG has been added. Now I will add one more subnet, subnet 2 with the so it is also creating 11 IP addresses, and the network security group is going to be subnet NSG2, and then click on OK. So what it is, we have created two subnets, each having 11 IP addresses, and for each subnet we have attached a security group associated to that one. Subnet 1 will have RDP plus web access, subnet 2 will be having only MS SQL access but denying the HTTP port. So now you have created the virtual network, you have created the subnets, and you have created the NSGs. Okay, so now we have created a VNet with two subnets, subnet 1 and subnet 2, and we have created two network security groups. One is for subnet 1 by allowing RDP access and HTTP, and for the other subnet we have created another subnet called subnet 2 NSG, where we have allowed MS SQL and denied the HTTP. So now let us create under one subnet 1, let us create one virtual machine with Windows 2012 R2, Windows 2012 R2 VM, and the subnet 2 consisting of another virtual machine with MS SQL server. Okay, so let us go ahead and create in the virtual machines. Let us add. So I'm going for this one. Let us go ahead and type virtual machines first, and then virtual machines, and then to create a new virtual machine, maybe I can delete this one. Why necessarily the amount waste? Okay, let me click on add. So for what we require to create is like we require to create a virtual machine, right? So first give the virtual machine name under which resource group. So record org is the resource group, and the virtual machine name is maybe we can put subnet 1 VM. Sorry, spelling mistake. Subnet 1 VM, and under which region? East US region. In the availability options, we have availability zone and availability set, which we haven't discussed, which we will be discussing while talking about the virtual missions service. Right now, just put it as no infrastructure redundancy required. What is the image? So we thought of creating an image. We thought of creating a OS with Windows 2012 R2, right? So click on browse all images on this, and select Windows Server 2012 R2 data center. So I have selected that one. And what should be the size? So the size you can select so the size here you can select actually whatever the size that you want. By default I am selecting the basic one itself. That's enough for this demo. So under the administration account, what should be the user ID, username and the password for this virtual machine? So I will be creating demo VM and demo VM demo VM $123 and then demo VM $123. It should consist of at least 12 characters. So once this is done, so we have already given, see, as I said, the NSGs can be applied at the subnet level and as well as at the virtual machine level. We have already applied the NSG at the subnet level. In addition to those rules, if you would like to add any extra rules for this virtual machine other than the NSG, then you have to select those rules over here, allow specific ports here and all those things. But I will be selecting the same subnet one, so I will be selecting none here. And then if you have brought your own license already, Windows license already, then you can select yes and then provide your own license. Otherwise you will be you can click on no. So click on next this. I will not be making any modifications over here because I will be discussing these things during the virtual missions. Right now we are concentrating on virtual networks, so I will be skipping these things. So now this is the location where you should be selecting under which virtual network you should be creating, under which subnet. So I have correcting VNet test 1 and the subnet 1. So these are the two things which I should be selecting. Click on management, just off. Okay, remaining things are not required. Just click on review and create. So what I am doing here, I am creating a virtual machine under a virtual network VNet test 1 and the subnet group subnet 1 NSG, so that automatically the NSG that is added to the subnet will be applicable to this one, so that I should be able to do the remote desktop for this one. So I have created this. So it is currently doing the validations. Once the validations are done, then it will allow me to create the virtual machine. So this indicates that I will be creating a Windows 2012 R2 virtual machine. And yeah, let me click on create. Validation is done. So meanwhile, till this is getting created, let us go ahead and click on virtual machines and let us create one more virtual machine for the backend purpose. That is for the subnet 2. So I will create resource group, same thing, record org. So I will be selecting here subnet 2 db. Let me put it as it subnet 2, sorry. Okay, till that time let me go ahead and create virtual machines and resource group is RG and then the virtual machine name subnet 2 DB. I want to create a DB server, right? So region is East US, availability zone, just select no infrastructure redundancy required, and under the image now we require to have an SQL, right? So go here and type SQL server. So let me select Windows. We have selected 2012, right? So let me go down. Yeah, Windows Server Service Pack Enterprise on Windows Server 2012 R2. Yeah, this should be fine. Let me select the standard one. Okay, so resource manager, create. Okay, so now here if you see it is going with the world important. So virtual machine name is subnet 2 db. Just put as it is and then put demo vm $123 demo vm $123, and subscription is free trial, and the resource group is record rg, location same as it is. Click ok. So virtual machine size, let it be the default one. Let me put the minimal one. Settings. So here I should be selecting the subnet 2. So this is what I should be doing. So other than that, remaining things I have already selected this one, subnet 2. Next, click OK. The port number is 1433. It is already selected, so no issues. So I'll put public internet with virtual network. Here I can put virtual network. Click OK. Yes, it is doing the validation now, and then I'll be okay. So I'm creating the database server as well. So meanwhile, let me see whether this has created so I have created one virtual machine with web application. Yeah, so one is getting created and it is running. So in order to connect to that one, go ahead and select the IP address and then click MSTSC, because you should be having a RDP permissions. So click on this one and more choices. So demo VM, password is demo VM $123. So now I should be able to log into this one. Yep. Okay, so it is allowing me to log in. So that is what actually, with the help of NSG group that you have added, now you are able to log into this one. Yep, yeah, you can see that you are able to log into this one. So that is what actually, so by this one you are able to create a network security group, you are able to create a subnet, you are able to create a virtual missions inside that subnets, and then you are able to create a virtual network. So next topic we will be discussing about site to site connectivity and the point to site connectivity and the express routing. Thank you, that's all about this video.